This is section 4.1. It's on classifying triangles. In geometry, a triangle is a figure formed when three non-collinear points are connected with segments. Each pair of segments forms an angle of the triangle. The vertex of each angle is a vertex of the triangle. So here's a triangle. The three vertices or vertexes of the triangle would be these 3 points, D, E, and F. Your three sides of the triangle would be segment DE, segment EF, and segment DF. And your three angles of the triangle would be angle D, angle E, and angle F. If you were to name the entire shape, you would use 3 letters. But remember, we've already used 3 letters before to name a plane. We've used 3 letters before to name angles. So if you're going to use 3 letters to name a triangle, you need a little symbol to put in front of it. So if you make a little triangle symbol and put it in front of your 3 letters to name your triangle, then this is read triangle DEF. Now, there's no order for which you need to name the letters for the triangle. So for example, you could call this triangle DEF. You could call it triangle EFD. You could call it triangle FED. The order doesn't matter, and what you start with doesn't matter. We're going to classify every triangle that we see by its angles. Before we even start this, it's important that you know that every single triangle in the world has 180 degrees in it. So the 3 angles must add to 180 degrees always. Acute triangles are triangles where every single angle is acute. So every single angle here is less than 90. And of course, they all add up to 180. Obtuse triangles, one angle is obtuse. The other 2 must be acute. Think about that for a second. It would be impossible to have 2 obtuse angles in a triangle, because if you did, that would be more than 180 degrees. So this adds to 180. To be obtuse, one of the angles is obtuse. The other 2 are acute. Same concept with a right triangle. One angle must be 90 degrees for it to be a right triangle. The other 2 must be acute. 180 degrees total. We're also going to classify triangles by their sides. Scalene triangles have 0 congruent sides. So here's a good example of a triangle where all of the side lengths are different. We could take a step back for a second. I know these are angle measures because of the unit. Look at the degrees. I know these are segment lengths, again, because of the unit. Notice how this is centimeters. It's a length. Okay, so if they're all different, it's a scalene triangle. If at least 2 of them are the same, we're going to call that isosceles. If all 3 sides are the same, we're going to call that triangle equilateral. Now, by definition, equilateral triangles are also considered isosceles because isosceles triangles have at least 2 congruent sides. So this is an isosceles triangle, and this actually is an isosceles triangle as well. Okay, here's another little hint that we're going to get to later, but it's going to help you a lot now. If all of these sides are congruent, there's going to be 0 congruent angles also. So these angle measures, whatever they are, they're all going to be different. If 2 sides match, there's going to be 2 angles that match. So there'll be 2 congruent angles. And if the triangle is equilateral, then all of the angles will match. So there's going to be 3 congruent angles. Now, if you stop for a second and think about that, if they all add up to 180 and they're all the same, in an equilateral triangle, all of the angles are going to be 60 degrees.